Hey guys, so we are going to look at finding slope and y-intercept given graphs. So far we've been working with linear equations. We've found slope with 2 points. We've found slope and been able to describe if it's puff puff positive or nice negative. We've done all sorts of really fun things with slope. So now we actually have to look at y-intercept too. Why? Because in our next lesson, we are going to be creating equations given slope and y-intercept. If we have those two things, we can create anything when it comes to lines. So this is a little tricky to see, but hopefully we can see it. What's kind of cool about graphs is we can see our slope and our y-intercept pretty easily. We already know how to find slope. Essentially, we look for two nice intersecting points on lines. And this particular line has a lot of them. You can look at the two that are described here. We can look at two that are closer together. It doesn't really matter. We just need to look at its rise over its run. I'm going to look at both in this one so we can see the rise is 1, the run is 2. And remember, when I look at slope, I'm looking from left to right. So I'm looking at a point more further left compared to a point that's further right. I'm looking at how much it goes up or down and how much it goes to the right. So I can look at those 2 points and I can say rise over run. The slope is 1 over 2 or 1/2. I can also look at this in terms of like a bigger thing. So if I wanted to look at this in terms of dots that were further away, the 2 dots that were marked here, I have a rise of 3 units and a run of 1, 2, 3, 4, 5, 6 units. So again, 3 over 6 simplifies to 1/2 when I divide by 3 on the top and the bottom. Cool. So slope is pretty easy to find with these graphs. What's also nice is we can usually find the y-intercept pretty nicely too. The definition of y-intercept is this, where the line crosses the y-axis. In this case, the y-axis is right here. It's this bold line on the left-hand side of our picture. This graph here crosses the y-axis at a point that's really easy to see at 0, 3. And we take the information right here, this 3 part, the y-intercept or the y value in there, and we can label that our y-intercept. So a couple of things. When I want to write this out, I will say my slope, or m, I can either write m or slope is 1/2, and my y-intercept, we call that b, which we'll understand more in our next lesson. We call that b, and that is 3. You could also write it as 0, 3. Just be sure to understand that when we actually put it into the equation, it's just this 3. Now, what if our graph isn't quite as nice as this one? So check this out. I have another graph that we are going to look at. Let's see if I can bring it up on the screen. Here's another graph that we are going to look at. We now need to look at this graph and say, okay, what is the slope and what is the y-intercept? The reason why this graph isn't as pretty is 1, we're going up by 2s for every single one of these units, so we have to keep that in mind. And 2, our y-intercept is not on our graph. And that sometimes happens, and that's frustrating, but we have to deal with it, and we have to be able to problem solve this. So first things first, a nice way for us to start problem solving the y-intercept issue is actually finding the slope, so that way we can use the slope to work forwards or backwards to find our y-intercept. So we have 2 nice points on here, 2, 18, and 6, 6. We are going to find our slope with these 2 points using those 2 nice points. If I look at my leftmost point and compare it to my rightmost point, I am decreasing a whole lot of units. And remember, each one of these squares is 2 units. So I'm going from here at 218 and moving down to my y value of 6. So I'm going down 12 units. Then from there, I am going to the right 4 units. And again, we can look at these x values versus the y values. And this 4, 2 plus 4 gets me 6. 18 minus 12 gets me this other 6. Kind of cool, huh? I like that. Yay. So we're kind of using the slope formula to our advantage when we're looking at these problems. So my slope, which is rise over run, in this case it was a drop. So a rise of negative 12 over a run of 4. I can then simplify by dividing by 4 on the top and the bottom, and I get negative 3 over 1. So my slope is negative 3. Cool. So now I'm going to use this information to work myself backwards to find the y-intercept, because if I go further to the right, I'm getting further away from this y-axis. I need to go further to the left to get to the point where I can see the y-intercept. All right, so if I were to use this slope of 3, I would be looking at partial units. I would say, okay, for every 1 that I need to go backwards, I need to go up 3, and that's kind of awkward. What's kind of nice about slope is I can scale it up or down as much as I need. So we have this slope of 3 over 1, and for every x, 1x, I need to go back up 3. So I'm actually going to look at this and multiply it by 2, because I know each one of these units that is on my graph is worth 2. I'm going to multiply it by 2 on the top and the bottom, and I get negative 6 over 1, or over 2, whoops, 2, negative 6 over 2. And technically this negative could be attached to the bottom or like the bottom number or the top number. It just means that this slope is negative. So I'm going to use this and move my run backwards 2 units. That means my rise would go up 6 units. And I'd be able to say this line right here, it's y-intercept. I can spell. It's y-intercept. If I go and subtract 2 units here, I get 0. But add 6 units here, I get 24. My y-intercept is 0, 24. Or my b is 24. So I can use that to my advantage and sort of work backwards and scale my slope up or down however I need to be able to find the y-intercept. Kind of cool, right? I know. Super neat. My next video is going to be on tables. And then after we do tables and look for slope and y-intercept in tables, we will do one more like sort of practice video so you can see all of this in action one more time. And then you can start working on your must-do problems. Thanks for watching. Bye.